Questions 21 through 25 on the 2014 Grade 7 Gauss Math Contest. A bicycle at store P costs $200. The regular price of the same bicycle at store Q is 15% more than it is at store P. The bicycle is on sale at store Q for 10% off of the regular price. What is the sale price of the bicycle at store Q? At store P, the price is $200. At store Q, the price is 15% more than this $200. So it would be 1.15 times 200. And that is $230. Then they're saying that this $230 is discounted by 10%. So you take that $230 and multiply by 0.9 to get the new price. And when you do, you get $207. And that is the sale price at store Q. So number 21, the answer is D. Each face of a cube is painted with exactly one color. What is the smallest number of colors needed to paint a cube so that no two faces that share an edge are the same color? Well, let's draw a cube and let's talk about this. Well, let's see. You have to remember that each face has obviously four edges, right? So we know that if you have one face, let's say it's red, then none of those other four can be red. So that's the first thing to consider. And when you fiddle around with this, you realize that you can have a scenario as follows. You can have red, for example, as the front and red as the back. B for back, F for front. We can have another color for top and bottom. Let's just say it's blue. Blue for the top and blue for the bottom. And then we can have another color for the sides. We can have green here on the left and we can have green here on the right. And if you do it like that, you'll notice that the conditions are met, that no two faces that share an edge are the same color. And that's accomplished with just 3 colors. So number 22, the answer is B. 2 standard 6-sided dice are tossed. One die is red and the other die is blue. What is the probability that the number appearing on the red die is greater than the number appearing on the blue die? Well, let's talk about this. Since we have 2 dice, the first we have 6 possible choices of what will show up. And the second also has 6 possible choices. So the total number of choices is 36, right? So since 36 is not that many, I'll just write them all out. And then we'll come back and talk about it. So here are the scenarios. The first number represents the number on the red. And the next column, of course, represents all the numbers that could show up on the blue die. So we have to now look at these 36 and say, okay, which one of them are the scenario where the number on the red die is greater than the number on the blue die? All right, no problem. Let's just circle them. This guy, this guy, this guy, this one, this one, this one, these 4, and I believe these 5. These are the scenarios where the red die has a number that's greater than what's on the blue die. Well, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the probability is 15 over the total number of cases, which was 36. And that's it. And they don't even want you to reduce it, which is interesting. So number 23, the answer is C. In the diagram shown, STUV is a square. Q and P are the midpoints of ST and UV. PR is equal to QR, and VQ is parallel to PR. What is the ratio of the shaded area to the unshaded area? All right. The first thing I think to notice in this question is that since PR is parallel to VQ, if you were to continue that line that is going from PR, it will go all the way till T, like that. And in a very similar way, if you were to continue the line that's going from QR, it will go all the way until U like this. And that helps because that essentially means that if you were to drop a perpendicular from Q to P, this segment here, this area right there, that triangle QRP, is going to be much easier to calculate once we have that understanding. So let's just do this now. The ratio of the shaded area to the unshaded. So let's just figure out what is the shaded area. The shaded area, let's give it some numbers. Let's say this is 2. Since Q is the midpoint, this will be 1 and 1. Similarly, P is the midpoint, so this will be 1 and 1. So I can easily figure out this area of VPQ. So VPQ, 1/2 base times height. The base is 1, the height is 2. And then I have to add this triangle right here. And in particular, the only part that I need to calculate is that distance right there. That's going to represent my height. So the triangle QRP, 1/2 base, well, the base I can just use that top to bottom, which is 2, times height, which is that red line. But what is the length of that? Well, since it is indicating in this diagram that R is the midpoint of this rectangle, if you drop a line down from R to the bottom, it would basically be the midpoint of PU. And since PU is 1, the midpoint would be 1/2. So that means that this distance is 1/2, that red line. And there you go. And a little bit of interpretation, you can get this pretty easily. So this is 1 plus 1/2, which is 1.5. So that means if the area of the shaded region is 1.5, the unshaded region, US, unshaded region, would be the total area of the square, which is 2 times 2, minus the shaded region. So that's 4 minus 1.5, which is 2.5. And now finally, we will do the ratio, which is the area of the shaded region over the area of the unshaded region, which would be 1.5 over 2.5, and multiply top and bottom by 2, and you get 3 over 5. And that is choice B for number 24. On a coordinate grid, Paul draws a line segment of length 1 from the origin to the right, stopping at 1, 0. He then draws a line segment of length 2 up from this point, stopping at 1, 2. He then continues to draw line segments to the right and up, increasing the length of the line segment he draws by 1 each time. One of his line segments stops at point 529, 506. What is the end point of the next line segment that he draws? Well, if you look at this diagram, they've drawn obviously just the first few. And in particular, if you look at any point x, y, what will it be? Well, the x-coordinate looks like it'll be 1, and then 1 plus 3, 1 plus 5, and so on, right? So the x-coordinate will be 1 plus 3 plus 5, dot, 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 and so on. Whatever we end up until. And let's say we go until n. I don't know how far we're going, right? When I get to here, I'm not sure yet how far I have to go. But that's what the x-coordinate will be. The y-coordinate, if you look at it, it'll be going up. So 2 plus 4 plus 6, and so on. So 2 plus 4 plus 6, and so on, until we get to some value. And again, I don't know what it is, so I'll just call it m. But one thing I do know is that n and m are very close together. They're only 1 apart. For example, if n was, say, 5, m would be 6, right? So I'm not 100% sure yet, but n and m differ by 1, so let's just say n is equal to m minus 1. I could be off by 1. It could be n is equal to m plus 1, but this is a pretty decent start. Okay, so now they give us the big clue that eventually we're getting to 529 and 506. All right. Well, there's a quick way of doing this question. There's a longer way. The longer way sort of explains it a little bit better. And I'm going to do it the longer way just because I want to explain it a little bit better. But on a math contest, you do it in the shortest way possible. So because I want to explain it, I'm going to take this point, 529, and in a very straightforward way, assign this to be x and this is y. So this 529, since it's x, I'm going to use that formula. So 529 is equal to 1 plus 3 plus 5 plus ... until some n. And 506, since that y is 506, that's going to be 2 plus 4 plus 6 plus ... all the way till some m. All right. Now, you guys have a calculator. It's allowed on the exam. Some of you can easily just do this on a calculator. You can just get out in 1 plus 3 plus 5 plus 7 plus 9 plus 11 ... Keep going until you get to 529, and you'll be able to figure out your n. And then you can do the same thing here, 2 plus 4 plus 6 plus 8 plus 10, and you can easily get up to m. But these are kind of big numbers, right? They're not extremely big, but they're sort of big. So what I'm going to show is a formula. The first formula I'm going to show you is this one right here. When you have this kind of scenario, it's not consecutive numbers, it's consecutive even numbers. So we can factor out the 2. And when you do, you get 1 plus 2 plus 3, like that. And that is consecutive numbers. The 1 plus 2 plus 3 part. So that goes all the way until now m over 2. And this part has a formula. And some of you may know it, some of you may not. It's in grade 7. So you're in grade 7, so you may not know that the sum of consecutive numbers ... until n is equal to n times n plus 1 over 2. All right. So using that formula here, this part becomes m over 2 times m over 2 plus 1 all over 2. All right. So that basically, these 2's cancel out. So you just have m over 2 times m over 2 plus 1. And that, of course, equals 506. Now, at this point, I do not encourage you to multiply it out and use a quadratic, all that stuff. Just use inspection. Get out your calculator, take the square root of this, and see what two numbers multiplied by each other equal 506, right? And those two numbers are consecutive. So do a little bit of fiddling around. When you take the square root, you'll see that it's about 22 point something, right? So I think that m over 2 is possibly 22. Well, let's see. Take out a calculator, take 22, multiply it by 23, and indeed it is going to be 506. So there you go. M over 2 is indeed 22. So that means m is 44. Perfect. All right, now go back. Remember in the beginning I said that n is 1 away from m. So if m is 44, n is perhaps 43. So now I've got to go back to this formula and figure out what is x. Okay, no problem. X is 1 plus 3 plus 5 plus ... all the way until n, and that n I have chosen to be 43. Again, I would like to show you a formula. You can do this in a calculator without a formula. Formulas are not necessary, by the way. I'm not saying you need to, but it just makes it faster and also helps you learn a little bit more. The formula for this now, these are not consecutive numbers. These are consecutive odd numbers. That is not going to be this formula. It's going to be something else. And that formula is a little lesser known. This one is very well known. But the consecutive odd numbers, that one is a little lesser known. That one is n plus 1 times n plus 1 all over 4. And even if you didn't know this formula, like I said, don't worry about it. You can easily do this on a calculator. The 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 and so on all the way up until 43. If you do that, you get 484. Now you say, oh, that's not 529. Okay, no problem. All that means is that I just have to add one more because n is not 43 and is most likely 45. So add another number, and when you do, you get 529. So let's illustrate this in a very, very brief diagram. So that means we had a scenario as follows. We went this way, right up. We kept going right up. And then what happened was, let's just fill this in. We had 41 here, 42 here, 43 here, 44 here, and then 45 here. That's how we got to this point right here, which was our 529, 506. And now if we keep going, we're going to go 46 up to get to this point. And they're saying, what are the coordinates of that point? Well, if you go up 46 from this point, the x-coordinate doesn't change. It just remains 529. But the y-coordinate definitely changed. You have to add 46 to the y-coordinate. And when you do, you get 552. So that is going to be the end point of the next line segment that he draws. And therefore, number 25, the answer is A.